This is Jun14 SS02 paper, and this is a hypothesis test question. A company produces low energy light bulbs, and the bulbs are described as using 9 watts of power. The production manager, Amir, has asked Jenny to measure the power used by each of a sample of 120 bulbs from the latest batch produced, and they're going to test whether they think the mean is still at 9 watts. Jenny's going to carry out the test at the 5% significance level. First part of the question asks us what assumption must be made about the sample of the 120 bulbs if the result of this test is to be valid. That answer is relatively straightforward, and that is that the sample is random, and therefore if it's random we can use it as being representative of all of the light bulbs. Then in part B, Jenny found that the mean for the sample was 9.2 and the standard deviation was 1.3 from her sample of 120 bulbs, and we're asked to carry out the test that Amir has asked for. First thing that you do with any hypothesis test is to first of all start with the null and alternative hypothesis, which I've done here. The null hypothesis is the hypothesis of no change, so in this case it's that the mean remains, the population mean here, which is mu, remains at 9. No specification was given in the first part of this test as to whether or not we were to look for a positive increase or a decrease, so we're looking for a change away from 9, in which case it's a two-tail test at the 5% significance level. I always summarise this information because it helps me to find the critical values from tables later. So what I've now done is I've summarised the information that Jenny has found for us, that the sample means 9.2 and the sample standard deviation is 1.3, and I've used this to find my Z test statistic, which is here. I've used the formula x bar minus mu over S over root n. So 9.2, which is x bar, take away 9, which is the hypothesized value, over 1.3, which is the sample standard deviation, over the square root of 120, the sample size. And this gives me a Z test statistic of 1.6853. The next stage in my calculation was to find from tables the critical values. For 5% two-tail, I've gone to the formula book, and it's given me minus 1.96 and plus 1.96. Obviously, with it being a two-tail test and my 5% level of significance, it's 2.5% in either tail. My critical value of 1.96 when compared with the test statistic of 1.6853, the test statistic clearly does not lie in the critical value. On that basis, I accept H0, but I'm not quite finished. I must ensure that I do my contextual conclusion, and I conclude that there is no evidence that the mean of the batch differs from 9 watts. For the final part of this question, part C, the question just changes slightly. When Jenny reported the conclusion of the test to Amir, he said that he had intended to ask Jenny to test whether the bulbs in fact had used more than 9 watts on average. For the test in part B, state the effect that this new information would have on the alternative hypothesis. Well, the alternative hypothesis would change because rather than being not equal to 9 as it was before, it would now be that mu is greater than 9, meaning that it's a one-tailed test. The critical value would also change because now our 5% is going to be contained in just one of the tails, and the critical value would change to 1.6449. This in turn would lead us to a significant result because the final part we're asked for is whether it would affect the conclusion. The conclusion would actually change because our test statistic that we had before of 1.6853, this working would remain unchanged, is now actually going to be greater than 1.6449, so would lie in the upper tail of the and therefore in the critical region. So we would actually on that basis reject H0 and conclude that the mean of the batch, the use of electricity that was used by the light bulbs of the batch, was indeed more than 9.